All right. So last time around, we talked about a few examples of how to apply the concepts of objects on inclined planes and resolving forces to solve questions from the question paper. Today, we talk about a very important section of the chapter of forces, statics, and that is friction. Friction has this sort of a chapter dedicated for itself because we will be talking about this new concept within friction, and then we're going to merge this concept with all the other things you have learned so far in order to solve sort of slightly difficult questions. All right, so let's get started now. the fr- so the idea of friction is quite simply it's a contact force, number one. Number two, it acts in a direction that opposes motion. Okay. So it's a contact force, meaning it has to exist when two objects, two surfaces are in contact with one another. So, um, number one, it's a contact force and it opposes wait, what's the spelling? Oppose opposes, I hope that's the correct spelling, opposes motion or supposed motion, meaning even if the object is not moving, with friction would act in a direction where if the friction was to be eliminated, the object would move, right? So I'm going to repeat that. Supposed motion, meaning it acts in the direction opposite to the direction where in which an object, if the friction was removed, would move, right? So supposed motion. Now, um, that is what friction primarily is. All right, it most of the times we think of friction as being a nuisance because it results in the formation of thermal energy, basically heat that is dissipated and kind of hampers efficiency of machines and whatnot. However, friction is a very important force when it comes to um, objects that are moving. For example, cars. I mean, walking, for example, and all kinds of you know even air resistance is a kind of friction where the air molecules coming in contact with any object that's falling uh, does help the object reach terminal velocity. Otherwise, the object would have hit the surface very hard. So all these things do give friction a fair amount of application, right? So that is what friction theoretically is. Now, in this chapter, we will be talking not only about friction in general, but also about a very specific kind of friction, which is known as limiting friction. Okay. Now, this idea of limiting friction is not all that complicated. It's actually pretty simple. So let's start and try to understand what limiting friction is about. And we're going to do that by looking at this example where a block is sitting on a surface and you are pushing the block with a certain amount of force, 5 Newton. But you notice that the block is not moving. And obviously, the reason for that would be that, and your deduction would be that there's a friction acting in the opposite direction. Friction. And you can also deduce that the value of friction is also equal to 5 Newton, right? So friction is equals to 5 Newton. However, you're adamant and you continue to increase the amount of force on the block. So the next stage, you push it harder 6 Newton. You still see the object is not moving. What is your deduction then? The same object, the same surface, with you giving an increased amount of force, is giving you the same result. It's not moving. Your deduction is friction has now changed to 6 Newton. And this is possible. This is how it works. I mean, if you think about it, let's say you have a massive table in your room, and you exert a small amount of force and the object doesn't move, right? It has to mean that your force is being balanced by all the friction between the floor and the table. But you try harder, you exert a bit more force, but you still see the object is not moving, the table is not moving. That must mean the friction is now balancing out your new force. And this may happen for a range of forces. You can even apply a 12 Newton force and you can still see that the object is not moving. Your deduction meaning your deduction is in that case that the friction is also 12 Newton. And this is not really surprising. I mean, you can try this at home. You can start pushing a very heavy object with increasing amount of force, and you will realize that for a range of values of pushes you exert, the object remains stationary. And in every case, your deduction should be that the reason it is stationary is that the friction is balancing out your exerted force. In this case, friction balanced out your force of 5 Newton. In this case, friction balanced out your force of 6. In this case, friction balanced out your force of 12. Not more, not less. Exactly the same as the force that was exerted by you, right? Imagine if this wasn't 5 Newton. Imagine if this was 3 Newton instead of 5. তখন the block would have accelerated, right? Imagine if this was 7 Newton instead of 5. তখন the left force is greater and it would move to the left, but we know that doesn't really happen in case of friction. The whole idea is friction exerts or tries to exert as much force as necessary, or in very dire situations as it can, as it possibly can, in order to oppose the the motion. তার মানে কি, তুমি 5 নিউটন দিয়ে ধাক্কা দিছো, এই সারফেসটা 5 নিউটন দিয়ে ব্যালেন্স করে ফেলবে, 6 নিউটন দিবে না, 3 নিউটন দিবে না। তুমি 6 নিউটন দিয়ে ধাক্কা দিতেছো, এই সারফেসটা 6 নিউটন দিচ্ছে। And remember, this is the same surface, this is the same block, all right? So there is a point to be made here. And you've increased it further to 12 newton, and still there is a 12 newton force, and the object is not moving. That must mean that the friction is 12 newton. But there always comes a time when you are strong enough, if you do exert a strong enough force, the object starts accelerating or moving, okay? And even if it's for a few seconds, as you continue to exert the force, the object keeps on moving. And why is that the case? That is the case because the reason the object starts moving is because um, the friction is not enough to overcome the force that you are exerting. Okay, meaning you're exerting a 12 newton 15 newton force, but the friction is definitely less than that. তার মানে you have overcome the friction, and as a result the object starts moving. And in some case, this kind of friction that needs to be overcome in order to get the object moving is called static friction. Okay, static friction is the friction that is exerted uh, throughout the process of throughout the process where the object is still stationary. Okay, Now, give me a second. All right, we're back. So the reason that this object starts moving is probably because the is because the is because this 50 Newton um, is greater than friction. All right, but we're not really sure how much. I mean, we need to do some math in order to do that. But let's say, for example, the value is 13 Newton. Just a second. So let's say this value is 13 Newton. Now, the reason this happens, the reason the object starts moving is because 13 Newton, and according to this statement right over here, friction should exert as much force as is necessary to oppose the motion. But why is this object moving? It must mean that friction is failing to exert the force necessary, meaning this is the maximum friction possible between this surface and this block. And friction is trying its best, but it cannot increase beyond 13 Newton, right? So that is the maximum possible friction. I mean, if you remove a bit of if you make the surface more rough in any way, add some sawdust or anything, maybe this maximum ability, the maximum friction possible, will increase. তখন হয়তোবা একটা রাফ সারফেস যদি হয়, আরেকটু রাফ সারফেস যদি হয়, হয়তোবা ওইটার ক্যাপাসিটিটা বেড়ে যাবে up to 16, 17, 18 নিউটনস, ঠিক আছে? তখন more force would be necessary to get it moving, right? So this concept right over here, where a surface tries to exert as much friction as needed in order to oppose motion, but only up to a maximum possible value, is the whole essence of what we call limiting friction. So what exactly is limiting friction? It is the maximum possible friction between any two surfaces. Any two surfaces. So think about it. If you have two different surfaces, uh, two different, let's say, roads, for example, one road is a bit slippery, the other is a bit rough. একটার মধ্যে বৃষ্টি হয়েছে, আরেকটাতে বৃষ্টি হয় নাই। যেটাতে বৃষ্টি হয়েছে ওটার ম্যাক্সিমাম ফ্রিকশনের ক্যাপাসিটি কমে যাবে, মিনিং ইটস লিমিটিং ফ্রিকশনস ভ্যালু উইল বি স্মলার দ্যান দি আদার, যেখানে বৃষ্টি হয়েছে, right? And that is why the same block, right, the same block, if on the slippery surface, will not require much force. অল্প একটু ধাক্কা দিলে it will start accelerating. The same block, right? It's because friction on the slippery surface is smaller. In other words, or more specifically, limiting friction is smaller. ঠিক আছে? So that is something you need to keep in mind. Any questions so far? Okay. Now, what dictates the value of limiting friction for two surfaces? ঠিক আছে? So limiting friction, let's call that FRLIM, friction limiting, is proportional to the normal contact force. So greater the normal contact force between the surfaces, greater the limiting friction. And when we get rid of, and that kind of, should give you the idea that heavier surfaces are more difficult to move, not only because of inertia, but also because the heavier the surface, more the value of limiting friction, and thus, sorry, more the value of normal contact force, and thus greater the value of limiting friction. And that is one of the contributions, যে যত ভারী অবজেক্ট হবে তত বেশি তাকে ফোর্স দিতে হবে to get it moving. So friction limiting, when you get rid of the proportional sign, you need to introduce a constant of proportionality, and then in this case the constant of proportionality is given the symbol mu. Okay, mu, okay, and multiplied by the normal contact force R. This is a formula you must remember. Limiting friction is equals to mu R, where mu is called the coefficient of friction, and this changes from surface to surface. Slippery surfacer mu এর value কম, rough surfacer mu এর value বেশি। আর হচ্ছে the normal contact force। জি বলো।
Coefficient of the friction নাকি coefficient of the contact force?
কি
Coefficient of the friction হবে নাকি coefficient of the contact force?
না
কারণ mu is multiplied to r না।
হ্যাঁ, বাট এইখানে এটার নাম দেওয়া হয়েছে coefficient of friction. It has nothing to do with r. It is completely dependent on the surface, and that it completely influences the value of the limiting friction. So it's called the coefficient of friction. ঠিক আছে? So that is something you need to keep in mind. যে this is the normal contact force, আমরা যেভাবে শিখছি normal contact force বের করা, আর this is the coefficient of friction. So this is the jackpot formula of this chapter. Okay? So remember a few things. Number one, limiting friction, and like we said, limiting friction is the maximum possible friction between two surfaces. And number two is that friction, basically the same thing, friction between any two surfaces cannot exceed the value of limiting friction. It's pretty much the same thing, maximum বেশি তো আর যাইতে পারবে না limiting friction. So এইটার একটা mathematical inequality আমরা বানাইতে পারি যে in any case তোমার সিচুয়েশনে তোমার যদি ফ্রিকশন থাকে, ফ্রিকশনটা is always less than or equal to the value of the limiting friction. Or in other words, friction is less than equals to mu r. So এটাও মাথায় রাখতে পারো ডিপেন্ডিং অন দ্য সিচুয়েশন। এটা মানে কি? মানে হচ্ছে এই এক্সাম্পলটা দেখো, বারে বারে বলতেছি যে this is the same situation, just changing the value of the forces. The same surface, same block, and we said this is the limiting friction, right? And notice করো, the value of the friction 5 in stage number 1, it was 5. It was definitely less than equals to, mu r being the limiting friction 13. 6 friction দেখো 6 less than 13 আসতেছে, 12 less than 13 আসতেছে। In other words, যত যাই হোক না কেন, in any situation, if you never know the value of the limiting friction, or if you have a friction's value, যেটাই বল না কেন, you have to keep in mind that the friction will never exceed the value that is calculated by the product of the mu and the normal contact force. তার মানে সবসময় একটা জিনিস বুঝে নাও, কিন্তু সবসময় কিন্তু লিমিটিং ফ্রিকশন অ্যাক্ট করবে না গাইস। লিমিটিং ফ্রিকশন is theoretically there. For example, in this case, 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 প্রত্যেকটা কেসে লিমিটিং ফ্রিকশনের ভ্যালু কিন্তু 13ই। As long as the surfaces are the same, the value of the limiting friction is 13. But was 13 required in all the cases? No. 13 was only required in the last case. In all the other cases, in all the other diagrams, 13 was not required. এখানে 5 Newton was enough. এখানে 6 Newton was enough. Enough to do what? Enough to stop the motion. এখানে 12 Newton was enough to stop the motion. এখানে 15 নিউটন লাগতো, বাট আমার ইনাফ নাই, আমি 13 নিউটন, যেহেতু আমার ক্যাপাসিটি ম্যাক্সিমাম এই সারফেসের, 13 দিয়ে দিব। So maximum friction or limiting friction will not always act. Friction values that are smaller than limiting friction could be acting, but limiting friction will act at the very last stage. Last stage মানে হচ্ছে যখন the force causing the motion or is trying to get the object moving is very large. ঠিক আছে, তখন ফ্রিকশনটা যতটুক পারে দেওয়ার চেষ্টা করবে টু অপোজ ইট। Sometimes it will be able to stop it. For example, imagine করো, if this wasn't 15, if this was 13, তাহলে কি ম্যাক্সিমাম ফ্রিকশন ঠিকই রিচ করছে, বাট 13 এর সাথে ব্যালেন্স করে কিন্তু ইকুয়াল করে ফেলছে। So that was enough to still keep it in equilibrium. So I'm going to add a diagram right in the middle. What if this was the case? What if this was the case? 13 Newton দিচ্ছ and friction ও 13 Newton. The object is still at rest, not moving. এটাও কিন্তু not moving. তুমি যদি আর একটু ফোর্স বাড়ায় দাও 13.2 নিউটন বাড়ায় দাও ফর এক্সাম্পল, তখন কিন্তু মুভ করা শুরু করবে। This kind of situation has a special name and we're going to discuss this. It's called limiting equilibrium. And what does this mean? An equilibrium, whoops, limiting equilibrium is a situation where the maximum possible friction or limiting friction is acting and all the forces on the object or the particle are balanced. তাহলে এখানে কি হচ্ছে, this is an equilibrium, this is an equilibrium, ঠিক আছে, the first diagram, but this is not a limiting equilibrium because the friction is not a limiting friction, it is not the maximum friction that's possible. This is also a not a limiting equilibrium, this is not a limiting equilibrium, আর এটা তো ইকুইলিব্রিয়ামই না, এটা তো অ্যাক্সেলারেট করতেছে, but this right here is an example of a limiting equilibrium. ঠিক আছে, কেন? Because the maximum forces, the maximum possible friction is acting and at the same time it is all the forces are balanced. বুঝছো? So a few things to notice. Number one, some pointers, some points to remember. Any moving object, whether it's constant speed, accelerating or decelerating, has the limiting friction acting on it. ঠিক আছে, obviously it makes sense because once you, in order to get the object moving you need to first overcome the limiting friction, তাই না? So ওইখানে limiting friction ই পুরাটা act করবে, there's absolutely no point for any other value of friction to be acting. So for example, তোমার object যদি accelerate করতে থাকে thanks to your engine's force of 2000 newton, ঠিক আছে, and the friction that is acting has to be the limiting friction, মানে ম্যাক্সিমামটা দেওয়ার চেষ্টা করবে সারফেসটা, ঠিক আছে, no other value of friction would be useful here. So এটা মাথায় রাখতে হবে, ম্যাথস করার সময় এগুলো মাথায় রাখতে হবে। নাম্বার 2 হচ্ছে যে when an object,
ভাইয়া
জি বলো।
সবসময় কি লিমিটিং ফ্রিকশন অ্যাক্ট করবে?
না, এটাই তো আমি বললাম, লিমিটিং ফ্রিকশন সবসময় অ্যাক্ট করবে না, যখন দরকার হবে তখনই লিমিটিং ভ্যালুটাতে যাবে, রিচ করবে। এখানে এই প্রত্যেকটা সারফেসের লিমিটিং ফ্রিকশনের ভ্যালু, মানে তুমি চিন্তা করতে পারো দ্য লিমিট দ্য ম্যাক্সিমাম, ঠিক আছে, ইজ 13, কিন্তু কোনটাতে 13 দেখতেছো এই ফার্স্টের তিনটাতে না, বিকজ 13 তো লাগতেছে না। So here friction is acting.
এটা হচ্ছে এই সারফেসের লিমিটিং ফ্রিকশন, আর বাকি যেগুলো 12 নিউটন 6 নিউটন ওগুলো তো জাস্ট নরমাল,
ওগুলা এমনি ফ্রিকশন, ঠিক আছে, the friction that is acting, these are just friction acting, but we say that in all of these cases the limiting friction is 13, but the 13 newton is not acting. It's not acting because it's not needed here, it is only needed in this diagram or in this diagram, ঠিক আছে, যখন লাগবে তখন দিবে, আর যখন পারবে না তখনও ওইটা দিবে, যত মানে যখন দেখো 15 নিউটনকে ওভারকাম করতে পারতেছে না, সো ম্যাক্সিমাম যতটুকু দিতে পারবে ততটুকুই দিয়ে দিতেছে। সো এখানে একটা জিনিস বলো, when an object is in limiting equilibrium, the object or particle is um, or I should rephrase this, the phrases are associated phrases are about to move, comma, about to slip or slide, যেভাবেই বলো না কেন, on the point of moving, etc. এগুলা মানে কি? তোমার কোয়েশ্চেনে বা তোমাকে যদি কোনো সিচুয়েশনে বলে দেয় যে I have this object and I am exerting a 15 Newton force forward and the object is about to move forward, it means that the object is still not moving. The object is still not moving, but it is on the very verge. মানে আর একটু ফোর্স বাড়ায় দিলেই সে সামনে মুভ করা শুরু করে দিবে। But the current stage is still an equilibrium. And in fact, যখন তোমাকে একটা আইডিয়া দেবে it's on the brink, on the verge, about to move, মানে একদম লাস্ট মোমেন্টে আছে, তখন বুঝতে হবে it's an extreme equilibrium, it's the limiting equilibrium, meaning ফ্রিকশনটাও লিমিটিং কাজ করতেছে। মানে ফ্রিকশনটা একদম জান প্রাণ দিয়ে trying its best to keep it stationary. এখন যদি তুমি হঠাৎ করে এটাকে 16 করে দাও, ফ্রিকশন আর কিচ্ছু করতে পারবে না, ওই 15 নিউটনই থাকবে, 16 নিউটন থাকবে, সামনে অ্যাক্সেলারেট করে ফেলবে, তখন আবার ইকুইলিব্রিয়াম ডিসরাপ্টেড হয়ে যাবে। The same is true for about to slide or on the point of moving. For example, আমি যদি কখনো কোনো সিচুয়েশন দেখি যে এদিক দিয়ে তুমি রশি দিয়ে টান দিতেছো টেনশন, and তুমি যদি আমাকে বলো that the block is about to slide down, is about to slide down, এটা মানে কি? এটা মানে হচ্ছে, well, good thing you are pulling it up, but here is mg sin theta, it is about to slide down মানে the object is still in equilibrium but it is on the very verge of নিচে পড়ে যাওয়া, নিচে পড়ে যেতে নিবে, তার মানে কি ফ্রিকশন উপরে আটকায় রাখার চেষ্টা করতেছে, and this is not just any friction, this is limiting friction, it is limiting equilibrium। ঠিক আছে, সো এইটা মাথায় রাখতে হবে যে they will not only give you phrases like these, about to move, about to slip, slide, on the point of moving, but ওরা ডিরেকশনও দিয়ে দিবে, ওরা বলে দিবে the object is about to slide down, তখন তোমার মাথায় রাখতে হবে যে the limiting friction is acting upwards because even though the object is not moving, it is about to move, মানে at the very last point friction is trying its very best to oppose it by acting in the opposite direction. So these are few things, some theoretical ideas, some phrasings and wordings, ঠিক আছে, যেগুলো মাথায় রাখতে হবে if you want to tackle the questions. So